Following video contains mathematical content. Proceed with caution.
Right now, we start with the derivation of formula. As you can see, the formula is to calculate the sum of nth terms in a geometric progression. However, it is hard to use it because we don't know all terms. So, we need to create a formula to make it easier to count. We are going to use the elimination method. First, we are going to multiply equation 1 with r to create equation 2. And then, we are going to eliminate the same terms in both equations. After eliminating, we will get this equation. After that, we want to make s another subject. So, we simplify, which will get us this formula. But what if we do it differently? We do the same thing, but we change place of both equations. But now, we have two almost similar formula. This means that there are two conditions when calculating the sum of n terms. We got r is more than 1 and r is less than 1. Okay, now, what's this? This condition here is because common ratio cannot be 1. If you insert the value as shown into the series, we will not have a progression, instead just some random numbers. Now that we know the formula, we can applicate it into searching the nth term in a geometric progression by using this formula. Imagine you need to know the weight of the last piece of pizza, but you only know the weight of the pizza in the box only. You can use this formula for situations like this. That'll be all.
The first question for low-level question is, given that a geometric series is 1 plus 25 plus 125 plus 625 and so on, find the sum of first 10 terms. First, we must know the formula of a geometric series. And then we substitute the information that we get from the question and you get the answer for question 1. Then, the second low-level question is, it asks us to find the sum of the following terms. And as usual, we use the formula of a geometric series to find the answer for this question. In this question, we use the formula where r is less than 1. After you are done substituting the information given, and you'll get the answer for this question. That's it.
Okay, let's answer this geometric progression. So find the number of terms for the following question. So given this geometric progression question is 7, negative 14, negative 28, and the sum of first n terms of geometric progression is negative 2387. So we list out the a, r, and sum of the first n term of geometric progression. So a equal to 7, the first term, and r common ratio equal to negative 14 over 7, and we can get that common ratio is negative 2. So we can get that negative 2 is lesser than 1. So we use the formula sum of the first n term equal to a bracket 1 minus r power of n over 1 minus r. So we substitute the question. So we calculate the value and we can get that negative 2 power of n equal to 1024. So we use indices to get the value of n. So the n value is 10. So the number of terms for geometric progression is, this question is 10.
Find the value of n and the sum of n terms for the following sequence. For the first question, finding the value of n. So the first step to take is to find the value of a and the value of r. We can simply find a and r from the sequence given. So as we know, a is the first term of the sequence, meanwhile r is the second term divided by the first term, and then we will get a equals to 12 and r equals to 3. Then we will simply substitute the value of a and r into the formula, which is ar power of n minus 1 equals to 2916. When we are left with 3 power of n minus 1 equals to 243, we need to express both sides of equations in the same base. In this question, base 3. In order to find n, we will compare the indices. N minus 1 equals to 5. What we need to do is move negative 1 to the other side, which will make n equals to 6. Moving on to finding the sum of n terms. So in this question, we will use the formula of Sn equals to a in bracket r power of n minus 1 divided by r minus 1. Then we could simply substitute the values and we'll get the final answer of 4368. Moving on to b, we just need to apply the same steps as before. So a equals to 14 and r equals to negative 2. Then proceed to substitute the value into the formula ar power of n minus 1 equals to negative 7168. As usual, we make both sides have the same base number, which in this case is negative 2. To find n, we will take the indices of n minus 1 equals to 9. Then we will move the negative 1 to the other side to make n equals to 10. Finding the sum of n terms. In this question, the formula that we are going to use is a little bit different because r equals to negative 2, which means that it satisfies the condition of r is less than 1. Thus, the formula that we are going to use is Sn equals to a in bracket 1 minus r power of n divided by 1 minus r. Finally, we just substitute the value and then we will get the final answer of negative 4774.
A wire of 2046 pi cm long is cut and bent to form 10 circles. The diameter of each circle is twice the diameter of the previous circle. Given the smallest diameter of the circle is p cm. A. Find the value of p. B. Find the total area of the first 5 circles. To find p, we have to know the circumference first, which is 2 pi r, and then we equalize it with pi d, which is p pi. And our first term equals to p pi, and our common ratio equals to 2. And then we insert it into our formula, Sn equals to a bracket r power of n minus 1 over r minus 1 because our r is more than 1. And then we use S10 because we have 10 circles, and we will get p equals to 2. B, we have to find the area of first 5 circles, and the formula is pi r squared. When we list it down, the geometric progression, the first term will be pi and our common ratio will be 4. And then we insert the same formula we used previously, and we will get 341 pi cm squared